All right, third hour. Notes are ready. Go ahead and snap this stuff down. We'll talk about it here shortly. As you're writing this down, I'm favoring those that own a graphing calculator because you're supposed to. Bah. Okay? And that's how the notes are going to be constructed today because the whole graphing calculator list thing, that list feature, really comes into use with what's called divisor methods. All right? Oops, I don't have my pen, and I'll move out of your way here, over here, or a highlight there. Jefferson, and it is Thomas Jefferson, tied to his name, one of the founders of our country, um, came up with a different method to calculate how the House of Representatives would be given out. Now, our first example today is silly, and it kind of changes the game a little bit. Just, I don't know, be adults about it, but try to figure out how this, turns a little different. Not necessarily talking about House of Representatives. So it's called a divisor method because when you get a fail on the first try, like let's call it a fail when you use the Hamilton method and you don't give out all 300 seats. It only gave out 297. Not really a fail. But then what you do is the largest fractional part or the decimal, you give out the extra seats. It's not what you do with Jefferson. Let's call it a fail. You divide by the standard divisor and you don't hit 300 seats. What you have to do with Jefferson method, choose a different divisor. And you have to keep choosing a different divisor until you give out smack dab on the dot 300 seats. There is a fundamental difference right there. And what I'm going to tell you, how do you choose the modified divisor? You have to use mathematical common sense. And the reason I say that, if you were in my class last year, we did go over the mathematical structure that's presented in the book that the other teacher from 2 years ago, Mrs. McGrath, followed. Now, I'm not saying it's bad, but what it did was it led to a lot of confusion among the students. And by the end of the chapter, we all decided that just using mathematical common sense and changing the divisor was actually not that hard compared to how it was presented in the book. So, take it for what it's worth. I know in the beginning of a note structure, I throw out all these ideas because I know what I'm doing. You don't, so this doesn't make so much sense right now because this is brand new. But the first thing you're still going to do is the same old, right? We got to find D. And in the spirit of that question where we had 18 million people in that fantasy country, and then the number of seats they said they were going to give out was 300. That was 18 million divided by 300, which you got 60,000. Then you divided each state by that. So just reminding you of the two key components of step one. Step one is to find D, formula to the right, find Q, individual states quota, and then yet again round down. So this is 3 methods in a row that you just lop off that decimal part, round down. Okay? Now, more than likely, you will get a fail, meaning for Jefferson's method, not enough seats will be given out. Okay? So what you have to do in step 2 is choose a modified divisor and try again, trying to hit, if you remember the example from the beginning of the chapter, 300 seats on the dot. And we will actually do that. That's our last example of the day. Okay, now, how do you choose that modified divisor? I'm going to get my black marker right now and cross this out. This is not mathematically incorrect. That means it's mathematically correct. It just caused a lot of confusion with students last year, and it was a little overdone. Here's what you need to do to choose a modified divisor. If too few seats are given out, then what do you need to do? You choose a modified divisor that's smaller, because what happens when you divide by a smaller number? What does the answer become? When you divide by a smaller number, what does the answer become? Bigger. And that's what you want. You didn't give out enough seats, so you need to choose a smaller modified divisor to make the seats given out become larger. That's mathematical common sense. And that kind of got lost in this little mathematical structure that I blacked out over here. Again, I'm not ripping on teacher 2 years ago or the book. I just think as a whole, when we went through this for a week last year, we said, you know what, that's confusing too many people. Let's use some common sense instead. But I do want you to write these divisors down when you try them, even when you're going to your calculator. Make note of these things. Okay? So I think that's going to work out really well for us. We're going to be ahead of the game compared to last year's students. Not ripping on them at all either. I think after going over this a year as a teacher, this is much more doable. Do I have to go back up? All right. Did someone say something? What happened? Hello? Now this is kind of weird. So after you calculate the modified divisor, calculate the modified quota. So divide all the states in the state example by the new modified divisor and try to nail the quota total right on the dot. And if you don't do that, then sadly you got to choose another modified divisor. This is why I'm going to the graphing calculator, people. Because A, you're supposed to have a graphing calculator. It was required last year whether you were in CAT, meow, or this, what's the other class? Math 3. Okay, let's all be mature. I know we can be. This first example is kind of stupid, but I figured we're all mature. We were okay last year. And these are bottles of wine that are worth some money. So they're ones that you just kind of store and then sell for later. They're like investments. Okay, and let's say all the bottles of wine are of equal value. That's not ever really necessarily true. It really would be hard. Depends on who made it and what year it came from. But they're all equal in value, let's say. Because this one's a little strange. 4 friends decide to use the Jefferson Method, real cool people, to split up 24 or 25 bottles of wine. So how do you get this population? Or how do you get a population out of this? The members contribute money to a pile. And the money that they contribute to the pile, it emulates what the population is. So let's put this in terms of like, okay, Robert really wants a few of these bottles, but he's got $390, so he throws that in. And randomly he ends up, maybe it's a secret, they throw in how much money secretly. Then when they're done, well, Robert has a higher population. He's like a stronger state. So the dollar amount represents, kind of emulates the population that you're dealing with. Okay? And then what you could do is, all right, if that's the case, and then Monica is the smallest state with the smallest population, should get the smallest amount of representatives. She should get the smallest amount of bottles then out of this. So that's the method that they decide to do. So how do you get, as you're writing this chart down, I'm going to squeeze this back, or actually maybe go to this real quick, and then show you what this emulates here, and then we'll go back to the chart. So it's not a population and seats of House of Representatives. It's actually dollar amount. And then what we should do is we're giving out 25 bottles. So we divide by 25. And that's what I'm going to do first. And then the individual states population, no, that's the individual money spent divided by this new weird D that we created. So you understand that D is actually total money divided by the bottles given out. That's the representatives given out. And you can't give out a fractional bottle because we're going to keep those sealed, and then we're going to take them to our own place and maybe sell them later. All right? Blah, 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 blah. So I'll go back to the chart now for those that didn't finish writing that. Okay, for purposes of just getting used to the calculator again, although this is a very small example, very small. For purposes of getting used to the calculator again, let's use this. Then for large examples with large lists, no. For large examples for large lists, no. For large examples for large lists, yes. Okay, let me just bump it up a little bit. Oh. Samuelis wins that round. Okay. All right. We're going to type these in. 295, entry. 205, this is stunning video, entry. 390. And then 180. Oh, by the way, what am I going to divide by, which I should go back to my notes. Okay, I'm going to take and get my modified divisor, which I do have to keep this kind of on the small side here. And I'm going to take the total 1,070, total amount of money, which represents like our new population kind of idea, divided by 25. And I think I got 42.8. Can someone verify that? Please? Please, class. They never do anything for me. I sit here like a buffoon up here, waiting for someone to actually divide two simple numbers. Thank you, ma'am. Okay, now what I'm going to do is go up to L2 and hit second L1 divided by our initial divisor of 42.8 and see what happens. Now, in first hour, I showed some other buttons we can do, but it was kind of a waste of time. I may show them later to all the rest of the classes. When we have the original 13 states, when we have that example, you might want to see some more features. But what I'm going to do is go ahead and reveal on here what should be from your calculator 6.89, 4.789, which goes up to 4.79. 9.11, you only really need one decimal place. Because what do you do with these decimals anyway? You get rid of them. Or what's called rounding down your right. You didn't say anything wrong there. And what that is too few given out. So since it's too few given out, what should I do with the modified divisor? Increase it or decrease it? What should I do with the divisor? Increase or decrease? Why decrease? Modified D1, when you divide by a smaller number, what happens to these numbers? They go up. So what I did, I'm going to force it with you as well. We just went down to 42, which is going to give me modified quota 1 when I go ahead and divide by that. And then we're going to write those numbers in when I go to the calculator for that. So we're going to go down to 42 for a modified divisor, because when I divide by 42, these numbers should bump up. Now, will they go up to the next number or not? We'll have to find out. Second, L1. And I hope those that own a calculator appreciate this, and those that don't, you're naughty because you're supposed to. 7.02. What's 7.02 become? So this went up what? 1. But then all the others, 4.9, you really don't need much. This is still 4 because you just lop off the decimal. 9.3 is what that really rounds to. That's 9. And then 4.3 is 4. So what's this total if only one of them went up 1? So what do I need to do yet again? Modify the divisor. What's the modified divisor now? What do you think? What do you think would be a good one? 41 might be too much. Because you know who's going to end up getting it? Look at the progression. Who do you think is going to get the next bottle? Look at the decimals, how they're progressing. Michael, but make it happen. And he's close, right? So probably not going very much of a difference would matter. And again, we're going down because we want this to bump up. And because we're using the calculator, just go ahead and write the numbers down like this, like write what you tried, and then just copy the numbers from your calculator. Those that don't have a graphing calculator, you have to do these all by hand. And that's what's going to happen. So you can do that. It's okay. I do want you to write the numbers down, though, as you see them. Okay, 7.1. Still 7. No change from the middle column. 4.9. Did I make it? Oh, did I do the same thing? You know what? You were right, Chief. Let's just go ahead and finish, but I made myself mad. Did I get any change? Of course, what just happened there? How did both of these go away? Okay, 9.3. So I was wrong. You were right. You were right, Chief. 9, sorry. My brain's. Then 4.3. So, student said go to 41. I said, no, I bet you 41 and a half will work. And I was wrong. So we're going to do one last one. modify D3. We will do the student's idea, and the student will be right. Mr. Samuelis is wrong. Okay, then I'm just going to write the totals here for this one. L1, what in the blazes just happened there? Okay, so stat, edit, it's always fun, go up. L1 divided by, good job, students. Because then this one became 7. This one eventually bumped up to 5. These stayed at 9 and 4. Now we got 25. Okay? All right. So it happened. So, trial and error. Simple math understanding. Decreasing the modified divisor increases these numbers. And that's what you wanted to do in this scenario. Okay, then what I decided, and we're going, I think, a little faster than the other classes, which is fine. I decided to remind you of our previous examples. What was that? All right. So, remember, don't write this down. Remember the Hamilton method? You should love that one. The Hamilton method's easy where you do your divisor, but we are going to use this example again. So if you want to get right in the example, 18 million people, we're going to give out 300 seats. Here's the population because we are going to do this the Jefferson way. But the Hamilton method, remember, you do the divisor, you take the highest decimal parts, that's who gets the extra seats, right? And everyone did awesome on Thursday with that historical, what happened with our 13 states originally. And then we're going to close that off after we learn all the methods. We're going to do one more thing with that. And then here's Lowndes method again. Same states, same country, same start. 60,000 is your divisor. You end up with only 297 seats given, but then you get the smallest or the largest relative fractions. And we did awesome on that. Well, now we're going to do the same states. And I don't think with any of the classes I recognize the differences, which we could do. We're going to do the Jefferson method, which is the same first steps again. 18 million people, 300 seats, 18 divided by 300, or 18 mil divided by 300, 60,000. Divide everyone by 60,000, round down. We're short. So now, for the Jefferson method, which I'll hold off for those that are still right. Okay, so again, talking to the third hour real quick offline. Again, same steps. Jefferson method, you still 18 million divided by 300, 60,000 divided by 60,000, and you're below. So now, mathematical common sense. What should I'm going to give you one of two choices. Should my modified divisor change to 58,000 or 62,000? Which one? 58, he says in the back. Sounded like the voice in Shrek. Pick 3. Anyone know what that is from? Do you know what that's from? Do you remember that? Yeah, no? Pick 3. Modified divisor 1, he's right. Why? When you divide by a smaller number, the numbers will what? The numbers will what? Increase. So now my modified quota 1, I shouldn't have said mod, I should have said MD1. My MQ1 will be the following. And I think I could be able to follow along in a without having to draw these lines. So, did I type these in my calculator though? Oh no, I didn't. Okay, so offline, we're going to type these in my L1 list. All right? So, we're going to turn off the... So, now I type that in. There's the states. My calculator forces the E numbers, the scientific notation. I double-checked I didn't make any mistakes. Now I'm going to divide that whole list, divide L1 by 58,000. What I want you to do, though, is still write these down. And those that have to do this by hand, you just divide each one individually by 58,000 and write them down anyway. 74.5 added how many? How many did that add? 2. This is what we want to keep track of. I got a bad feeling already. 45.3. How many did that add? Aren't I already over? Okay, but I'm going to keep going just to continue with my mistake. Oh, my gosh. 85.6. So don't feel bad. You know, trial and error. this will happen, that you choose a modified divisor that swung way too far to the other side. And something worse happened last year where our tests were worse. It was. I believe. Now, what do we add? 2, 4, 5, 6, 7, 8, 9, 10, 11. So I added 11. 297 plus 11 is 308. I am way over. This is too large. Now, this is what I mean about common sense. Should I try 59,000? What do you think 59,000 will give you? An answer that's in between. I'm giving it to you already. An answer that's in between what? Look at the bottom. 297 and 308. What's in between 297 and 308 approximately? Like 303, 304? Isn't that still too much? So we just need a little bit of mathematical common sense to choose a good modified divisor in the next. What do you think that might be? It can't be over 60,000. We already did 60,000, and that was not enough. 59,000. You're on fire right now. I can't. Okay, let's slide it over. There we go. I could do that. 59,500. You want to choose a modified divisor that's closer to 60,000, not 59,000, because that will definitely get me a fail. That'll be between 297 and 308, which is like 303, 304. And 59.5 seems like the smartest choice for that. Now look at how fast I can go. Seconds, L1 divided by 59,500. Then lo and behold, boom shaka, anyone? Nobody? 72.7 is what, everybody? 72. No change from the original. But now I get 44.2, which is up how much from the original? 1. And then 83.4, actually 83.5, but it doesn't really matter. This goes to 83. And that's an add of what? 1. And then 51.1, which is an add of what? I've added 3. And I've only added 3. What's 297 plus 3? 300. This is the allocation. This is how it's going to be given out. So this is called a divisor method because you have to keep trying modified divisors until you give out the exact amount of seats you're supposed to after rounding down the decimals. All right? And again, I hope you understand why 60, 58, why we just didn't choose 59,000. We chose something closer to 60,000 because of how different these first two numbers were. All right? And that's the mathematical common sense that needs to come into play on this. Alrighty then.